So we're back for this is going to be the final video. This is page 2 of the multiple choice for part 7 Regents review. Getting started, right? I'm looking at the first one. I have two equations, right? It models the growth of two separate populations where t is greater than 0. What's the best approximation of time at which the populations are the same, right? So this is one, right? Once again, right, I know I could set these two equal to each other, right? But it's not really going to help me because it's going to be difficult to solve. So I'm going to put it into my calculator, right? When I plot both of these lines, right? I feel like this is like the fifth time we've done this, right? I get something that looks like this, right? My red line is 3t plus 2. Actually, I'm going to make that my blue line. All right, so my blue line is 3t plus 6. It kind of looks like this. And then my red line, right, is an exponential function, so it kind of is going to look like this, right? Now, right, it makes sense. There's one intersection point here, right, but on my little window on my calculator, it kind of goes off the window, but I know somewhere up here there's also another intersection point, right? So and they're going to give you both, right, as an answer choice, right? So if I'm looking, right, the first intersection point would be this like negative 1.9, but it doesn't work because t has to be greater than 0. If you kind of move that little cursor over to the right a little bit further when you do that intersect function, right, second trace intersect, you're actually going to get a value of 5.1, right? Which will be the point where the two populations are the same. Taking a look at number 7, right? Given f of x equals x cubed minus 3, or x to the power 3, yeah, x cubed minus 3. And you have this f of negative 1 of x, which is my inverse of x. What is the value of b, right? So I'm not going to worry too much about what b is until I actually do what? First, take the inverse, right? First step of the inverse is turn f of x into a y, right? So I would say, right, that's y equals x cubed minus 3. Second step, swap the x and y, so x equals y cubed minus 3. And then after that, I want to solve for y, right? So I'm going to add 3 on both sides. I'm left with x plus 3 equals y cubed. Right, in order to get rid of the cubed, I need to take the cube root of both sides, right? You see how I'm doing it over both of my terms over here. Cube root. That leaves me with what? Y equals the cube root of x plus 3. So that's my answer. Well, over here, right, in order to get this, everything looks right except I have an x minus 3b. Well, what am I going to have to put in b so I have a plus 3 over here? I put in a negative 1, right? Because if I put a negative 1 here, negative 3 times negative 1 becomes a positive 3, and that's what I'm shooting for. Hope that makes sense. That one's not too bad. Number 8, right? You're given the tangent is equal to negative 4 over 3, where the angle is between pi over 2 and pi. What is the value of the secant of the angle? So same thing, right? Whenever we have these problems, I'm making my coordinate grid. And right, if you remember about like when we were working with the unit circle, this will be an angle of 0, right? This is 90 or pi over 2. Two quadrants would be 180, right? Or just a straight up pi. And then I would have 270 or 3 pi over 2, right? So I know, right, where does my angle have to reside? It's got to be between pi over 2 and pi, which is in quadrant 2. So let me make my triangle really quickly, right? And it makes sense because tangent in quadrant 2 is negative. Tangent is opposite over adjacent. So my side here is 4. My adjacent side is 3. In order to find, I want to find my missing side really quickly, right? Using Pythagorean theorem, 4 squared plus 3 squared equals 25. And then the square root of 25 is 5. So that's going to be, right, an example of a 3, 4, 5 triangle. That's why I did it quickly. Well, now I go, right, and I know secant is the inverse of cosine. So let me just find cosine first, right? Cosine is of my angle is always going to be adjacent, right, side over hypotenuse side. So that means my adjacent side is 3. My hypotenuse side is 5. I know over here, right, also cosine has to be what? Negative, right? Because it goes all, sine is only positive over here, tangent's positive, cosine's positive. So I know it's got to be negative, right? But then I also know that secant really looks like this. It looks like 1 over the cosine of an angle, right? Which means that instead of it being adjacent over hypotenuse, it's hypotenuse over adjacent, which would mean it's 5 over 3, but it's also got to be negative. Answer choice number 1. Okay. And 2 more left. Number 9, right? It's actually giving you the first step here, which is to solve the equation. They want you to multiply both sides by the least common denominator. So I look at my 2 denominators. I got an x plus 7, an x minus 7, and another x minus 7. Remember, they're always going to kind of almost give you a hint, right? Because the least common denominator here is, right, LCD. It's just what? X plus 7 times x minus 7, right? It's the two. It's basically the two factors, right? So now I have to multiply this through to all 3 of my terms. This is where it's too much writing for me, right? Especially with the mouse. But I would want to multiply, right, this to my first term, right? When that happens, what's canceling out? The x plus 7s are canceling out, right? What am I left with? I'll at least write that out. That's 7 times what's left over? X minus 7, right? If I go now multiply to my second term, well, what's canceling out? The x minus 7. What's left over? That 4x times x plus 7. And then when I go to my other side of my equal sign, right? X minus 7 is canceling out. What's left over? X plus 7. So I'm going to be multiplying 3x plus 7 times another x plus 7. This takes a little bit of time, right, to multiply through, but it's all stuff you can do, right? I'm left with what, like 7x minus 49. I made a mistake over here too the first time just because I didn't pay attention to that x up there. 4x squared plus 28x equals, I FOIL a little bit, so I get 3x squared. I'm taking 2 steps at one time. 3x plus 7, that's plus 21x plus 7x plus 49, right? I want to get everything over to one side. If I subtract the 3x squared from the 4x squared, I'm just left with x squared. It makes me happy because it's going to make it easier to factor. I have 28x over here, and I'm subtracting what? Another 28x, and I'm left with over here a 7x. So that should also make me happy. 28x, those are going to cancel out basically. I'm left with plus 7x. And then I have a negative 49, and I'm subtracting another 49, so that's going to be what? Negative 98. And it all equals to 0. This is where right now too, they're kind of giving me hints what the factors are, right? I know one's got to be 14, one's got to be 7. So if I say, right, 14 times 7 is 98. So x, one's 14, one's 7. Let me see, right? This has to be positive. This has to be negative because they multiply to give me a negative 98, but they're going to add to give me a positive 7. What are my 2 values of x, right? The forever problem. X equals negative 14, and x also equals positive 7. But what does it ask me for? It's asking me for extraneous solutions, right? I go back up to my original problem, right? If I put in negative 14, do any of my denominators turn 0, right? Which would make it undefined? No. But if I put 7 in, right? If I put 7 into my second term or my third term, 7 minus 7 is 0, makes it undefined. This we cancel out. It's extraneous. What's my answer choice? Answer choice number 3, right? 7 is an extraneous solution. Whew. Last one, bringing it home. And it's cutting off answer choices 3 and 4. Can't help that right now. But you have a red-tailed hawk population is given this function, right, where t represents the number of years since the study began. Now, in terms of the monthly growth rate, the population can best be approximated by what function, right? So over here, right, and we didn't really go over this a ton. We talked more about like rate compounded monthly, right? But this is looking for the monthly growth rate. And honestly, it's really not that bad. You're just going to take what would be your normal rate, right? So in this case, my normal rate is 1.19, right? And if it's asking you for your monthly growth rate, what are you going to do? You're going to raise it to the power of 1 over 12, right? Because there's 12 months in a year. Just like if it was asking you for the weekly rate of growth, you would raise that to what? 1 over 52, right? So when I do that, what am I going to get? I'm going to get 1.19 raised to the power of, make it a fraction, 1 over 12. I'm left with 1.0146, or I'm going to highlight it over here, 1.015, right? That's the only one that has like that monthly growth rate. And then at the end, you have to multiply your time by 12. Honestly, not really sure why, but this is the only one that's got your monthly growth rate in it. Answer choice number 1, right? I wish I could give you a better explanation on why that works. The T might be just because it is, if you're thinking about the year, right, you're still going by years. So if you do 1 year, how many months did you do this rate by? You did it by 12 months, right? If you did it for 5 years, you're doing it by 60 months, and so you're doing your monthly growth rate 60 times, not the yearly growth rate. Maybe that makes a little bit more sense. All right. Thanks for taking this journey with me and dealing with my bad mouse writing. Maybe next year I'll make it better. And then also look for, towards the short answer part 7. It's just going to be with notes. All right. Good luck, guys.